You are about to be fixed. Physics Fixed. Better than real. Where each brief episode brings insight you've never had before by smashing through conventional barriers. It's Occam's razor in the hands of Jack the Ripper. This time around, Phyxed demystifies so-called intrinsic spin. That's it. We're done. In case you missed it, I'll review. Key to describing any spin is identifying its axis. But several generations have been taught that's not possible for spin-1/2. Of note, physically, this means it is ill-defined what axis a particle is spinning about. Any attempt to visualize spin-1/2 classically will badly miss the point. Quantum spin has nothing to do with motion in space, but is somewhat analogous to classical spin. Spin is often depicted as a particle literally spinning around an axis, but this is only a metaphor. Spin is an intrinsic property of a particle unrelated to any sort of motion in space. The spin of a fundamental fermion with no classical analog is abstract, with no possibility of intuitive visualization. Oh my, is that resignation to fundamental reality or complacency accompanying conceit? To avoid the latter, physics must be open to all reasonable models. An abstract mathematical model for quantum spin exists, but particles don't view quantum spin abstractly. It's an actual, universal behavior. Physics isn't physics if it denies a physical model. The distortion of conventional space-time coordinates makes you see what is not there, such as apparent length of a light-like interval. It also obscures what is there, quantum spin. That's about to be fixed, once again, with interval time coordinates, our Euclidean lens. We'll focus on the spin-1/2 of fermions, such as electrons. Having mass, these are conveniently considered in a rest frame. Spin-1/2 is real angular momentum with measurable components, recognized by conservation law. So a primary spin vector, sigma, on a real axis must be presumed. Classical spin resolves into component vectors along each coordinate, but spin-1/2 components don't sum to any classical primary. For example, if a spin component is measured as h⁻/2 on the x, then the y, then the z axes, a resultant spin of √3 h⁻/2 is expected in between. Instead, h⁻/2 is found there as well. That clue has never been fully appreciated. Here's why. A spin vector is defined as perpendicular to its plane of rotation, so it projects no components on a flat plane. A three-plane is a way to envision three dimensions all perpendicular to a fourth. The spin-1/2 axis can't be orthogonal with a spatial three-plane because non-zero components are measured there. But that doesn't prevent sigma being normal to an interval three-plane. Thus, Phyxed offers a model you've never seen before, and it's about time. Chronaxial spin is a descriptive term for spin about a temporal axis. More generally, it's spin about a particle's world line, which in its rest frame is its timeline. To reveal quantum spin, one must lift the veil of space. Phyxed accomplishes this with Euclidean interval time coordinates. With angles and local spatial flatness exaggerated for clarity, chronaxial spin has equal projections in all spatial directions. Half are negative, exactly as observed. No longer a coordinate. Space instead arcs past the spin-1/2 axis, like umbrella fabric over its handle, and consistent with last episode's curved space radial time model. A symmetric spin field thus projects in every spatial direction. All fermions age, so time undeniably supports translation, leaving no basis to deny that it also supports rotation. An objection to chronaxial spin might be that such hypermotion is essentially instantaneous, with circumferential speeds that exceed limit c. However, a fermion is a point particle of zero radius, avoiding such a restriction. Niels Bohr said, "However far quantum phenomena transcend the scope of classical physical explanation, the account of all evidence must be expressed in classical terms." Chronaxial spin is classical spin around a non-classical axis, time. So at the beginning when I said, this time around, Phyxed demystifies intrinsic spin, that was it in a nutshell. Congratulations! You're a halfwit, just like me. Are you ready for another quantum revolution? You'll never forget riding a bicycle next time on Phyxed. I'll see you there, if you dare. Ha ha! Check out Ben Schumacher's very accessible quantum mechanics lectures from the great courses.